I've got the privilege of guiding our discussion today. And to kick things off, I'd like to take a few moments to introduce Dr. Andrew Margenot. Andrew is a soil scientist at the University of Illinois Urbana Champaign, and his research team focuses on better understanding the biogeochemical processes that underpin soil function in agroecosystems. And in addition, he is fortunate enough to oversee the Morrow plots and the newly established alma mater plots, which are two very well-known long-term experiments that evaluate soil and crop management effects on agroecosystems. A major focus of his research group is the reduction of nutrient losses to surface waters in the Mississippi Basin. And on a more personal note, I should also add that Dr. Margenot and I worked together in the same lab at UC Davis. I was a postdoc at the time. He was a young up-and-coming grad student. So it's been really exciting for me to watch the trajectory of his career over the past few years. So with that, Andrew, I'd like to welcome you to the floor. The floor is now yours.
Thanks, Ryan. That was a nice introduction, and it's good to see you 13 years later. So thanks all for being here. And thank you also to the Tri-Societies for the invitation to present on this paper that was published, as Jamie said, in A&EL, and for Ryan for handling that as the editor. So today I want to share with you this more of a perspective piece. The backstory is that we set about to do a meta-analysis to test hypotheses on the fate of nitrogen from ammonium phosphates. As I'll talk about shortly, these are a common phosphorus fertilizer source, especially in the US Corn Belt, but there is obviously ammonium attached to the phosphorus, and so we are co-applying nitrogen. So we set about to do a meta-analysis concerning questions of what's the fate, crop uptake losses of this ammonium phosphate nitrogen, and there weren't enough studies to do it, so this became more of a perspective / call to action piece. So the goal for today is to walk through the background of ammonium phosphate fertilizers. There's a lot of emphasis on the Midwestern context of the US because that's where we see a lot of dependency on the specific form of phosphorus to meet crop P needs. And then we'll talk about the results of this study and some implications for future research. This is the paper that is the subject of today's webinar in Agricultural and Environmental Letters, published last July. It was co-authored with former postdoc Dr. Jung-Gu Lee, now professor in South Korea. And again, our goal here was to understand what is the fate of the nitrogen, both crop uptake and losses of ammonium phosphate fertilizers. And here we have in mind largely three forms of ammonium phosphates. We've got monoammonium phosphate, so MAP or MAP, diammonium, so DAP, and finally ammonium polyphosphate, or 10-34-0, which is not really used as a main P application. In corn production systems, it's a starter fertilizer typically. So the point is, we had this question of what happens to that nitrogen if we are thinking about these as P sources. So to summarize all this and leave time for some questions, ammonium phosphate fertilizers are largely an overlooked end source in global agroecosystems. They are 8% of global inputs, but when it comes to where that nitrogen is going, in terms of losses especially, there's not much. Probably because from agencies to researchers to crop consultants and farmers, we tend to think of this as a P source, and we don't really credit the N either agronomically or environmental. As a result, it's a blind spot. We're missing a good understanding of 8% of global N inputs to croplands. And this matters, as we saw in the case of the Midwest and of Illinois specifically as a case study, that there might be appreciable losses, largely probably mostly as nitrate, that's the hypothesis, but also N2O, which does matter for climate footprints. There's no study ever done that explicitly looks at dual loss pathways, and that would seem to be a very good next step for researchers. So some research needs, looking at the outcomes of the fall applied or spring applied, doing comparisons, MAP-DAP, also including a crop uptake assessment, going to the field scale. Those are two, I think, key priorities. In terms of what we do right now, before the research comes in. What could be done? Well, one is aversion, the other is mitigation. So switching sources or timing of application, and thinking about using things like inhibitors or coming up with coating and chemistries of ammonium phosphate types. Overall, I want to end on this theme that this is, to me, very low-hanging fruit when it comes to nitrate loss reductions across the Midwest and other cropping systems globally. It's rare that we don't change the main phosphorus application rate or the main N rate, but we simply change the P source to derive benefits for nitrate loss reduction. Not super intuitive off the bat, but it's a prime example of how if we can better manage the nitrogen of fall applied ammonium phosphates in particular, we stand to make large strides for nitrate loss reductions in the Midwest without really messing with the main corn N or P rates. That's a rare double win. So with that, happy to take any questions. Thanks for your time.